Okay, let's get started. Okay, so today we'll be on week 7. It will be on data structure. So the data structure in AP Computer Science A will involve the following different data structure. We will discuss one-dimensional array, two-dimensional array, also array list. Okay, some other data structures such as a stack, a queue, double-ended queue, tree, okay, map, and set. These are not actually discussed in AP ComSci A, okay? So we only limit it to one-dimensional and two-dimensional array, an array list. So first, you need to, let's review the reference data type. This one we discussed before. There are 3 reference data type in Java. That's class, string, and array, okay? These are 3 non-primitive data type and reference data type. And reference data type, your data will be stored in the heap area, okay? It will not be stored in the stack or stored in the global area. So you get a reference address value and that pointing to some location in heap, okay? Everybody hear me?
Yes.
Okay, make sure, okay? If you don't hear me, then I keep talking, then we may not be able to record it, okay? Sorry. So make sure that you hear me. So that is reference data type. This one, I think we discussed it before, so here I don't repeat it, okay? So basically your constants will be stored in the method area, your local variable stored in stack, your dynamic object stored in heap, okay? These are some concepts you must have. Okay, this one, okay, so in chapter 7, we primarily focus on array, two-dimensional array, and array list, okay? And class and string already been covered. So here, first thing is like, when do we want to use array? Okay, array is of the fixed length. The length is fixed. Okay, you cannot modify the number of the element in array. Okay, so program help an elevator know which floor will be on. So basically, your elevator from ground floor and then level 2, level 3 to level 10. The number of the level is fixed. So this one is suitable for array. Second one, Facebook keep track of how many friends you have. Your number of friends may grow, may shrink. Some people will unfriend you. Some people will add you as a friend. So the number of the friend actually is changing. So it might be better to use array list. Number 3, your program is going to simulate chess game and Candy Crush. Okay, this different cell phone game. So it will be better to use a two-dimensional array. Okay, cell phone, number of messages in cell phone, this one would be changing. So it's better to use array list, okay? And then a program to keep track of classes that you have. Each period of the school a day, usually these are 7 period or 6 period, okay? So it's fixed number of the period. So we recommend to use an array, okay? Okay, so that's the overview that before you use some data structure, you need to figure out which one is more appropriate, okay? Next one, we're going to talk about array, okay? So an array is a collection of data of the same type, okay? So we say double my list equals new double with 10 elements, okay? With 10 elements. So this one actually is creating an array, and totally there are 10 elements, okay? But this one, because 10 elements, you cannot save it to the stack, okay? So because it's, you don't know, you specify 10 elements, or next time maybe only 5 elements, okay? For example, you may have a double array D, okay, equals new double, and then with 10 elements. But you use it for a while, and later you may assign D equals new double with 3. So you may redirect to different location. Originally you pointed to one location, then later you may point it to a different location. So your array is only storing the address, okay, only storing the address. and then you actually look at the element, okay, you look at the element one by one, okay, one by one. So your address over here, that's so this address is called A, okay. So your first element will be at A address plus 0's location be your first element. So this one's double. This one's double type. So A plus A will be pointing to your first second index 1 location. Okay, this one is number of bytes. A number of bytes. So you can check the address in this way. But usually this address is consecutive, and we talk about this number as index. And physical address will be address plus the index times A. That is the size of the data type. In this case, it's double type, is 8. If you use integer, then the size will be 4. That's a 32-bit. Okay, depending on the number of bit, you will find the element there. And then you can create a predefined array. So integer array, int array equals this. This one is create an array with some data, okay? And this one is predefined data. And you can also declare an array using new integer 10. In this case, you will get 0, 0, 0, 0, 0 for 10 of them, okay? The initial value is all 0. Then you need to multiply the 0, okay? So if you declare only the reference data type integer array 3, at this moment, you will get the null value. You'll get the null value. And later, you assign the instantaneous data to the array. You have to put new integer array with the bracket and data over here, okay? You cannot do this, okay? You cannot assign only this portion. You cannot assign only the brackets, only this portion like this. No, this is not okay. If you assign a new anonymous data to an array, you cannot actually do without a new integer, okay? So new integer is not needed only when you declare the array and also assign the data right away to it, okay? Okay, so these are some definition of array. This portion, I go through it a little bit faster because we have many topics to cover today, okay? So array length is available to store how many elements in the array that you have, okay? Okay, and the new operator will be creating the reference data type, okay? So here, you use a class name and a new class, you will create an object and assign to the reference data type, okay? But here in array, when you do new, it actually will allocate in heap about the size of the elements, number of the elements in the heap location. And the initial value will be all zeros. If it's double, you will store 0.0. If it's reference data type, you will assign null to it. If it is Boolean data type, you assign false to it. If it's character, you will assign the character 0 to it, okay? So this is about the new operator. Okay, and okay, this one, okay, this is not related to array. So base array operation, you need to remember how to generate a random value to it, how to print it, how to find the maximum for it, how to collect a sum, how to do a swapping, okay? and how to copy the value from consecutive value, okay? So these are basic algorithm, and you should look at the slides and try to understand it, okay? Here, these are basic ones, so I don't cover it, I don't rewrite it, okay? I don't rewrite, these are very basic ones. Okay, then there are something you need to know is the index spaces, okay? You can create index spaces. Okay, this portion that's actually not continue the slides now. Okay, let's actually look at the program. Okay, let's look at the program. Let me see. Okay, the array type. So let's look at some program. Okay, let's look at some program. The first thing I would like to introduce in the program is the running index. Okay, the running index. So here, let me create a new project. Okay. So what is a running index? You must know about this concept because a lot of problem will depend on it. So let me create this one. Let's actually create a V6. Okay, V6 directory. Okay, so the first one I'm trying to look at is, okay, the first thing I would like to discuss is if we have an array, and our value is that we have 1, 2, 0, 3, 1, 0, okay? And if I want to actually move up the 0 in front, okay, how can I move up the 0 in front? Okay, this is the first problem that we will solve, okay? Okay, any questions so far? Hi, hello, any question? Luke Ma, you have any question?
No questions yet.
No question. So you understand this problem?
Actually, no, not really. Could you explain what's happening?
We try to move the 0 in front.
Oh, okay.
So how to do it?
Well, depends on if that's an array or an array list.
Wait, we are discussing array for quite a while, and you ask me that depend on array or array list. This means that you are totally off right now, okay? Let me choose another person, Katie, okay? Katie Wei. So how can we handle this problem?
You can probably like go through the array and search for the zeros, and then swap them with
them. Okay, you see a 0. Who should you swap with? So if I see a 0 here, who should I swap with?
The first element.
But first element may also have the 0.
Oh.
Then how can you find out the algorithm to solve this problem? Okay, anybody know?
Isn't there something called like selection sort or insertion sort?
This one is not sorting. Sorting is too much. Sorting is too much. Sorting will be unlock problem. Okay, that will be too much. Anybody else know it? How about Oscar? Oscar, you know it?
Wait, could you repeat the last couple things you said? Sorry, because my audio just died.
This is also not acceptable. We have been discussing this problem for a while. Please pay more attention, okay? We are doing review. That means that this one is actually, we try to cover things for your exam. So it's not acceptable that you just log in and then put your microphone away and then watch your video game, okay? That's not acceptable. Please pay attention to it. This is your chance to learn and to review your material, okay? Okay, so the sense that we want to move up the 0 in front of every non-zero one, okay? So how can we do that? So this one, Amy, you just log in. Can you say something?
Hi, yeah, sorry, I was at another class.
Yeah. Okay. Do you understand what we want to do?
No, I just walked in.
Okay. Anyway, look like nobody know how to do it. Okay, it's okay. So this one, you try to move the data to the front. Okay. So let's do move. Okay, this program, let's call it move. Okay. So, but it's very important that you pay more attention to the class. Otherwise, we go through it and then you say, well, I don't know about this, please repeat again. That's not acceptable, right? If you are a teacher, you will get mad, right? We spend time with you and then you say that I don't know. Please repeat again. Okay, how about we have such a list? Okay, and we are going to move 0 to the front. Okay. So here we have a program that will move the data to the front. Okay. And then we get the data in, we get the array in, and we are going to return an array with a 0 go to the front. Okay. And if you are not interested in the course, I would suggest you just to go watch TV or play game. Okay, don't waste your time sitting here and getting no result. That's wasting your time. You play game is even better. You have fun, right? And sitting here without listening to the lecture, you would have no fun, right? Okay. Anyway, here we are trying to move the 0 to the front. So this one we use a technique called running index. Okay, we call the technique called running index. So what we would do is like, okay, we go through the array. So we use an I that goes through it. So I will go through it one by one. So 1, 0, 4, 3, 2. I'm sorry, 0 and 1. Okay, sorry for that. So I keep going to here, and then I would have another array over here. So this one would be a new array, B array. Okay. So I see a 0, I move 0 to here. I see a 0, I move 0 to here. And then after that, I move the 1 to here, 4 to here, 3 to here, and then last one is 2, so move 2 to here. So that would actually complete this packing operation. Okay. So Amy, is that okay this time?
Yeah.
Knowing what we want to do? Okay.
Mhm.
Good. Now let's do it. Okay. So now the first thing is that we need to go through the data. So I equals 0, I less than a the length. Okay. And I increase. So basically we go through each data. Okay. And then we need to create a new array. So this new array will be B array. That will be new integer. How many elements? It will be the same number of elements as A. Okay, so we create that. And at the very end, our A will be what? We will actually do what? We will do a return my B array. Okay, my B array will be returned, and that will be the new array being created and will be returned. Okay, so here, let's do this one. Let's actually try to move the data. So to move the data, we need to have an extra counter. Let's call integer P. P was set to 0, and we call this one called running index. This is running index. So what's the purpose of the running index? Here we have 1, okay, 0, 4, 3, 0, 2, okay. So when this I keep running, okay, I get access to each element in A. So we have B array, okay. So B array will be pointed by P. So initially, first location you will put 0 in is P at 0. So when you see a 0, you move that 0 to here, okay? And then you increase your P to 1. And then you see the second 0, you actually put 0 to here, and then you increase your P to 2. And then you finish all of the 0 portion. Now it's time to move the non-zero portion. So you put your 1 to here, and you advance your P to 3. and then put your 4 to here, and then you advance to 4, P to 4, and you put your 3 to here, and then you advance your P to 5, and then put your 2 to there. Okay, so that's the operation we'll do. So now what we would do over here would be your B arrays P's value will be equal to, okay, here we will do this if actually A's I's value equals 0. Okay, if it is equal 0, then we'll do this. We'll do B's P's location value will be equals A's I's value. So we move all the 0 to there, and after we copy it to B array, P must increase. Okay, so this one we finish all of the moving for 0 portion. So now let's copy the whole thing. Okay, put it over here. The second for loop we traverse through the array one more time, and here we set it to be non-zero. That's it. That will perform the move. So here system.out.print line print out our array. So array s.to string. We print out our A array. Okay. Okay. We print that out, and then we will do move. Okay. So we would do move. So our integer, okay, sorry, your A will be equals move your A. Okay, you create a new array in B, but the B will be assigned back to A. So your original data is A. Now you actually get a new data. So your original data is this. Your original data is 1 0 4 3 0 2, right? And you make a copy to B. Okay, so A is here. You copy everything to B, and B become this, right? Okay, and later when you return, your A originally pointed to here. Now later outside, the return value B being assigned to A. So actually A also pointing to this new array. Okay, and the original one being original one link being cut. So A no longer pointing to the original array. And with that, okay, with that, we can print out our A array one more time. Okay, so we will see after packing, we'll see the data after packing. Okay, is that okay? Any question on this move array, moving using the so-called running index technique? Any question? Hello, hi Amy, is that okay?
Yeah.
And here you can simplify it. You can put the A++ over here. You can take out this P++ here, okay? That's actually legal. And that will make the program shorter, okay? And I do not do it first time because I want you to see the safer version, okay? If you are not familiar with the moving, that's okay. Now, if we want to move the 0 to the end, okay? If we want to move the 0 to the end of what? To the end of the array. Let's actually copy this one, okay? And put it into a C array, okay? So C array with the same data, okay? Now we want to put a 1 4 3 2 in front, and then 0 at the end, okay? And then 0 at the end. So what we would do is similar to this one, but we will actually copy, okay? And this one we will do move right. Okay, this function is called move right. We will move right, okay? So now you will create a new array called B, okay? And then you only put your negative, your non-zero one in first, right? You only put in your non-zero one in, okay? And that's it, okay? That's it. You can actually copy this one, put it over here. Okay, I only change the array from A to C. Okay. Okay, copy this one. If you have question, you must ask. Okay, must ask. I'll try my best to explain to you. So this one, I would say, copy 0 not needed anymore. Why is that? Okay, let's run it first. Run it first. Okay, I'm sorry here. I must have some error. Okay, so here I'm using B and not equal 0. We copy to it. Okay, this one I should use a move right. Okay, I actually use a move. That's wrong. One more time. Okay. Okay, so 0 will be put it into the right side. But this one, why I do not need to copy the 0? And I just copy the non-zero element to the left side. It will be good enough. Okay, this one, Grace Jean. Okay, why I don't need to copy the 0 one to the right?
You don't need to copy the 0 to the right because you are automatically going to the next position.
That's because when you knew the integer, everything is 0. When you knew the B array, everything is 0. You originally have 1, 0, 4, 3, 0, 2. Okay, and you create a new array, it's all 0. Everything already has a 0 there. And you copy the non-zero in, you become 1, 4, 3, 2. That's it. Okay. So here, after the execution, your P pointed to here is in 4. This 4 also tell you how many non-zero element is. Okay. This P value also tell you how many non-zero element they are. Okay. Go back to this one. Go back to the first moving one. You finish the first pass to copy the 0, 1 to the front. The P of the first for loop will have the value of the number of 0. So at this moment right here, P will be equals 2. Okay. Any question about it so far? Hello, Natasha. Are you okay?
Yeah, I'm okay.
If you have question, must ask. Okay. I'm trying to give you some idea of if there are some problem that is how to solve it. Okay, how to solve it. So here I'm moving to the left and moving to the right. Okay, and then put a 0 to the left or to the 0 to the right. Okay, this is called transcopy. Okay, this is called transcopy. Okay, that's one thing we learned here called transcopy. Okay. So that's transcopy. We finished one transcopy pattern. Let's try different transcopy version now. So let's do conversion. Okay, conversion. So let's assume that we have a one-dimensional array. Okay. So here let's have a static, okay, integer, okay, array. A, this one is an array. So it comes with the data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, 11. Okay, let's assume that we have such a data. And we also have an array, integer array. This one is B, okay, it actually equals, let's use this one, 10, 20, 30, 40, 80, and 60. Okay, so this one is a B array, okay. So now the question is, okay, now we have one-dimensional array. So how about can I assign this one-dimensional array into the two-dimensional array? So let's assume that I have a 3 by 3 matrix. Am I going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9 into here? How can I do it? Okay, how can I do it? Okay. So let's copy my one-dimensional array to two-dimensional array, okay? Some problem like this will happen, okay? Will happen in the exam, okay? They do happen before many times, okay? So this is very important. So here we have a two-dimensional metric. So here, new integer, okay? We create 3 by 3, okay? Now, how can we copy the array to M, okay? But before we do copy to M, let's actually print out M. So we need to print out M several times. So let's public, okay? Static print metric, okay? So void function print metric. Given the metric M, how can you print out the content of M? Okay, so here we do for integer row, okay, row equals 0, row less than M the length. This two-dimensional array, okay? And then row increase. So this one goes through each row of the matrix, okay? And then we do this one. So the end of each row, you need to change line. You need to change line. So we print the change line first. Now we go through each row. So each row has many columns. So columns starting from 0, column less than the row's length, and column increase, okay? Okay, so here we have two-dimensional array. It's called M, okay? It's called M. So this M is 3 by 3, okay? 3 by 3. Okay, so in fact, two-dimensional array is not like this, okay? In fact, it's like this. In fact, it's not organized in this way. It actually is like this. You actually have a M, but stored with some address. This address is pointing to an array of integer array, okay? Here you have a two-dimensional array. That's a metric. It pointing to one-dimensional arrays. It actually is M0. M0 is one row. M1 is another row. M2 is another row vector. So you actually have these three addresses over here. And it pointing to yet another location. So this one, it goes through another array of 3 elements. This one go to another array of 3 elements. This one also go to another array of 3 elements. So two-dimensional arrays organized like this, but conceptually it's like this. Conceptually it's like this one, okay? So basically here you have 1, 2, 3. That's a row 1, 1, 2, 3. And you have 4, 5, 6. That's row 2. You have 4, 5, 3, 6 over here. And then you have 7, 8, 9, 7, 8, 9 in the row 3. Any questions so far? So real data is organized in this way, but conceptually you look like having a matrix. It's two-dimensional array. Any questions so far? Henry, are you okay?
Yeah, I'm good.
Okay. So how can you say the length of a column? How many elements in the column? How can you say it?
What do you mean? How can you say it? You can like.
How can you specify how many columns in a row?
How many columns in a row? 3?
Yeah, 3. And how do you? This one we already specify 3 by 3. But if you are given M, how can you figure out which how many columns in a certain row?
Let's say it's like A and B to define. So instead of 3 and 3, it's A and B. Then there will be B columns in each of the A rows.
Yeah, but variable wise, how can you specify them? If we give
Not
you A,
entirely
B,
sure what that means.
if we don't give you the number, how can you figure out from M?
M dot size?
No,
Like, is that a thing?
no. Number of column would be the rows length. Number of row is M length. This one is number of row. This one is number of column. Is that okay?
Yeah.
So for example, if this one is 3 and 4 here, so M length would be 3, MR length would be 4. If this is 3, 4. Okay. Yeah, okay. So I try to figure out whether you know it or not. Okay. So nothing wrong if you don't know, but you better try to catch up. Okay. Not only you, I think everybody. Every time I ask question to student, many students just answer no question, no question, but in fact they don't pay attention to the subject. Okay, that's not really good. But this one actually is two-dimensional array. Okay, so you go through each row and then you go through each column and you try to print out the element. So you actually will print out the element. Okay. And you print out the element, and here we say actually percentage 3D, okay, that actually is 3 space, and we put our M of the row and column. That's actually 1 cell, okay, and we will print out the data in this way. So let's do this one, okay, let's do this one. Okay, so we do public, okay, static, okay, row name. So let's do print the metric. So at this moment, the metric actually is all 0. So when we print out the metric, you should get all zeros. Okay. So that actually is a metric. Okay. It's actually your original metric is all zeros. Okay. So after that, I'm going to print out a extra line. Now I'm going to copy a one-dimensional array to this two-dimensional array. Okay, but before I do that, I will actually copy this one, paste over here. I'm going to create a function that's called reset the metric. Okay, so give me a metric. I'm going to reset it. Okay, I'm going to reset it. So this one, instead of printing it out, okay, I'm going to reset the array. So reset the array, each cell I access them, I'm going to assign 0 to them. Okay, so this one reset. Now I'm going to copy the A to my array M. Okay, so here this one is the next one. This one we actually copy. Okay, static. Okay, boy, copy 1D to 2D. Okay. So you have a 1D array A, you're going to copy to two-dimensional array M. Okay. So now I'm going to copy one-dimensional data to two-dimensional data. So one-dimensional data right now is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So I'm going to copy to two-dimensional data. So 1 will be assigned to here, 2 assigned to here, 3 assigned to here, 4 assigned to here, 5 assigned to here, 6. Okay, so that one is pretty simple. So we do copy from 2D to 1D. So we copy the whole thing here, put it over here because we visit every cell, right? We visit every cell, and then we do not need to print out it. Okay, so the cell's value will be coming from A array, okay? And which A's element should you assign to? You will actually do integer P, okay? Put in 0 here. And same thing here, I'm going to use the running index to copy the element to the running index and copy to here, okay? But this one is buggy. Okay, this one has some problem, but let's do it first. Let's do it first. Okay, let's do it first. This one is buggy, but let's do it first. So this one is copy 1D to 2D. Okay, put it over here. Copy A to M. Okay, after that, let's print the matrix one more time. Okay. Print the matrix one more time, and let's actually run it. And you get the data. It's actually 1, 2, 3, 4, 5, 6, 7, 8, 9. As we actually specify. Okay. So that's correct. Okay. So every time you actually get the data from the 1D array, you have 1D array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You copy to 2D, right? It's over here. So you put into this cell with 1, put into this cell with 2, and then 3, and then 4, 5, 6, 7, 8, 9. Okay, 10 and 11 will not be put in because you run through your 2-dimensional array. 10, 11 will be extra. So that will not be copied in. Okay, so this one is okay, but that's actually reset our matrix. Okay, reset will bring it back to 0. Okay, so let's reset it. Reset is this metric. Okay, M. Reset this metric M, and then actually let's copy extra line over here. Now we reset it, and then this time I'm going to copy 1-dimensional array from B to M. Okay, from B to M. So from B to M, actually it will create trouble. Why? Because B is shorter. B is shorter. B only has 6 elements. We copy to M matrix. Then what? You need 9 elements. So some of them, A will run out of the index. Okay, so let's run this one. You will have a trouble. You will run out of index. So you do see array index out of bound problem. Okay, so this one is wrong. So how to fix it? How to fix it here? You must have the if P actually is less than A the length. If your P index is not running out of bound, then it will be okay. So this one, 1D, 2D, 1D to 2D. Okay, this one will solve the problem. Okay, so with that, your 1D to 2D is okay. You copy 1, 2, 3, 4, 5, 6, and the rest of them you don't copy data to it. So your P is protected. It will not go out of bound. So this is another technique of doing a transcopy. Okay. Any question? Any questions so far? Hello, any questions so far? How about William? William Zai, are you okay?
Yeah, I understand it.
Okay, next one. Next one is column major. Okay, if I don't want to copy it in this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead, I want to copy 1, 2, 3, 4, 5, 6, 7, 8, 9. We call this one column major. So you copy to every column first. So every column, same column, different row, same column, different row. Instead of running this way, okay, we actually try to do this one. It's actually column major copy. Okay, original one we call it row major traversal. Okay, and now we do column major traversal. So let's copy this one more time. Okay, we are going to copy the 2-dimensional array to 1-dimensional. Okay, but this one is column major. Previous one, this one is called row major. Okay. Okay, we are going to copy it to a column matrix. So we will rewrite it. Okay, we'll rewrite it. Okay, so right here, after that, we will reset our matrix one more time, making sure that the matrix is all zeros. Now we are going to copy. Okay, we are going to copy the two-dimensional array to one-dimensional array to two-dimensional array. Okay, so this one we still copy A to M one more time. Okay. But here we will do column major. Okay, and after that we will print our matrix one more time. We'll print out our matrix one more time. Okay. Okay, so we'll print out our matrix one more time. Okay, so we will do that. So now originally it's row matrix, so your row go by different row. Now you need to actually set up your P. Okay, I'm sorry. P equals 0. Okay. So you go through every column. Okay, so column equals 0, column less than M's R. Here we don't have R. Number of column we don't have R, so we will use 0 instead. Okay, because you don't have the R, your outer loop you don't have R over there, so you need to do this. Okay. This is number of the rows. So you traverse to some column first, and then you traverse to each row in that column. Okay, in that column, and then you steal a copy from A to the cell MC. Okay, cell MRC. You copy the same thing. This one will finish the column major conversion. Okay, so 1, 2, 3. So actually is column major. Any questions so far?
Just like in column major, instead of doing that, you could simply just switch R and C in the if statement, right?
Switch R and C.
Like you can just copy from.
No,
from,
the length of the row may not be the same.
No. Like the force. Okay, so the for loop stays the same as copy 1D to 2D. You don't need to change that for loop. All you have to do is in the if statement, if P is less than A dot length, instead of MRC, you switch it to MCR. Yeah,
but that's actually dangerous because you forget about, so if you do C here, R here, sometimes you forget which variable is R, which variable is row, which variable is column.
Right, sure, yeah.
That's one thing. Second problem you may have is actually, right now you are using 3 by 3, but you may have 2 by 4.
Yeah. If C and R are different lengths, then yes, this wouldn't work. Yeah.
You will have problem. Okay. So we don't suggest that. That's actually the wrong way to do it. We don't suggest that. That's not safe. Okay. But it's a good observation though. Okay. What you say is a good observation that you do not need to, you can understand that actually switching the two can save effort, but we do not recommend that way. That's dangerous, especially you may use the wrong length. Okay, here the length is calculated in different way. That's the first topic we talk about. What's the length of the column over a same row? How many column in a row, and how many row in a column? Okay, those are basic concepts you need to have. Okay. Okay, so this one very important, okay? And we do work on this one before, but not a lot of students submit the homework. So I'm surprised that you have no problem. This one actually in the Moodle course location, the first problem in The first problem set in the McGraw-Hill already require you to work on the column major, okay? But look like nobody asked the question. Not because you know it, but because you haven't worked on the problem set. That's the problem, okay? So at this moment, I do not see enough turn-in for the problem, for the practice set, okay? That actually is a problem, okay? If you don't practice, you're not going to improve, okay? And you don't see where you are wrong. So that actually is a problem. But here we repeat to talk about this, the so-called column major or row major copy, okay? Okay, anyway, that's, please submit more homework, okay? That's the only thing I can tell you. Now let's actually work on some other things, okay? So one-dimensional array, we talk about trace copy, that's very important, okay? So right here, I only work up to the column major and row major. Next one, we need to look into the searching problem, okay? Linear search and binary search, okay? You need to know about the index system and also reverse of the array element, okay? So let's look at this one called reverse. Okay, let's work on the reverse first. Okay, reverse function for an array, there are several ways you can do it, okay? So that's actually, okay, let's copy, let's create a new array, that's actually a array. Okay, so right here, let's have 3, 5, okay, 4, 1, 2, okay. I'm sorry, the first one should be 3. Okay, this one I'm going to copy several versions so we can use it later, okay. Okay, so here actually import java.util.star, okay. So now we are going to perform reverse on A, okay. So we will print it before the reversal. And then we will print it one more time after the reverse, okay? Okay, so right here we do have A equals a reverse of A, okay? Now we write a function for reverse. There are several ways you can write reverse, okay? Let's try different way of working on the reverse function. Okay, so first one is reverse one. Let's have an array A and try to reverse it. The first way is called swap-based reversal. Okay, so swap-based reversal, you have 3, 5, 4, 1, 2. So you swap 3 and 2. You swap 4, 5 and 1. You swap 4 to itself. So this one, you should go through the array. Okay, how many times? 5 divided by 2. So actually 2 times. Okay. So what you should do is actually here for integer I equals 0, I less than a the length divided by 2. Okay. I increase. Okay. So this one, this is half the length of the array. Okay. So if you are odd number, you actually have 5 elements. Divided by 2 is 2. So you only swap index 0 and index 1. Okay. So which element you should swap with? Now, which element you want to swap with? So here your index is 0 and your number element is n. So you want to swap with the n minus 1. Okay, so n is actually a the length. So when you have a 0, you want to swap with n minus 1. You have 1, you want to swap with n minus 2. Okay, so n minus 1 is n minus 1 minus 0. N minus 2 is actually n minus 1 minus 1. Okay, so this 0 is this 0. This 1 is this 1. Okay, so your I location will swap with n minus 1 minus I. Okay, this one is a symmetric location. Is okay? This one pretty important. That's called symmetric location. Okay, so you have a element here, I. The swap location you will have will be n minus 1 minus I. This one we call it symmetric location. It's symmetric to the center. That's the location you want to swap, okay? So here you are going to swap the two elements. So integer temp equals A's I's location's value. A's I's location value will be assigned by the symmetry location. That's A, the length, minus 1 minus I. Okay, that's your symmetric location. And then you will assign what? You assign A, the length, minus 1. Okay, minus I, I'm sorry. And then you will assign A, the length, minus 1 minus I's location with the temp value. Okay, and you will finish the swap. So here, if don't return, it's okay. It actually is destructive. Your A already been swapped. So right here, but you can still return A if you want it. Okay, if you don't return it, it's also fine. So let's try. This one is reverse 1. Okay, so let's do reverse 1. Okay, is reversed. Any question about this one? Any question? Hi, Demo, are you okay?
Yeah, I'm fine.
Most important part is how to calculate the location that you are symmetric to, okay? That's reverse 1. Let's look at another version that we can do reverse, okay? So public, okay, this is the first way we do reversal. That's actually you do swapping, okay? Swap base is the one way you can do it. So here we do reverse 2. Reverse 2 is not using swap base. We don't swap, okay? We don't swap in reverse 2. So instead of swapping, we actually create another value called B array. Okay. B array we actually created, and eventually we are going to return B array too. Okay. So now we are using the transcopy base. So we have 3, 5, 4, 1, 2. So we copy our 3 to the end. Okay. Or we copy 2 to the head. Either way, okay. Either way will work. But let's try copy the 3 to the end of the array, okay? So let's try this. Let's try copy from A's index 0 location to the end of the array. And this is 0. This location is actually n minus 1 minus 0, okay? Same thing, you still need to use that technique. So now we do this one. We do for integer I equal 0, okay? I less than A the length, okay? I increase, okay? And we do this, we do B's one location, A the length, minus 1 minus I equals A's I's value, okay? You copy to the new array's symmetry location, and that will solve the problem. Let's also give you the reversal. So right here, that's actually target. Here we use a B value, B array, okay, B array, reverse 2. Okay. Here, let me print a separate line separator. Okay. Is that okay? So this one, creating a new array, and you actually do find the symmetry location. Okay. Any question? And we can create number 3. Number 3, we don't use the symmetry location. Okay, we don't use a symmetry location. We actually use an integer. Okay, running index p, and this running index p will be equals a the length minus 1. That's the last element. Okay, that's the last element. So right here, I actually say p minus minus. So p will decrease every time you assign a value. Then p will decrease. You starting from the last element, and then you decrease. So that will also work. Okay, that will also work. So this one, we copy this whole thing and put it over here. Okay. And here we put the string C, okay, array C over here. And this one reverse 3, okay. So this one is using transcopy technique, okay. So what we would do is right here we have 3, 5, 4, 1, 2, okay. That's your A array. Your A array, I keep running in this way. So now your B array is over here. Your initial P is over here, right? So you copy the 3 over here, and then P decrease. After you copy P decrease to this location, right? And then you put 5 to here, P decrease. Okay, you put 4 to here, P decrease. Keep doing that, you will get it. So this one you don't need to calculate your symmetry location. Is that okay? So these are 3 ways we can do a reverse of the array. Any questions so far? One using swap base, one using symmetry location, one using running index. 3 different versions to write, okay? Eric, are you okay?
Yeah, I'm okay.
Is that too hard so far or okay?
No, I'm following just fine.
The things that whatever I'm talking about is about the same level as AP FRQ's level, okay? So I do not go over the boundary for it, okay? I'm reviewing the algorithm. So what you should do is right here is that you attend this lecture, but after class, what should you do? You should rewrite the program by yourself, okay? Rewrite how many times? Rewrite until you can fully understand it and repeat it by yourself without referring to my code. You kind of delete this, redo it again, and until you don't need to refer to my code. Okay, is that okay? That's the way to process it. Even me, I have a reverse problem. I don't solve it with one version and being satisfied. I try different way to write it. Okay, that's actually the way to study computer science. Always doing experiment, trying different way to write the same program over and over again until you become very familiar with the topic, okay? You cannot say, okay, I copy from certain book and that's it. I find the resource, so I understand it. I can submit a homework. That doesn't count, okay? If you cannot remember, it doesn't count. Okay, so these are different reverse functions, okay? These are different reverse functions. Now let's look at the conversion one more time. So last time we do have the metric, okay? We do have a metric, we print the metric, we reset the metric, okay? And we do copy 2D to 1D to 2D, okay? And you can do copy from 1D to 2D to 1D as well, okay? But we don't do that, okay? So let me copy the whole thing here. I'm going to do something else, okay? I'm going to do something else. So here, let's do flipping. So flipping is another topic you may see the problem in FRQ, okay? So let's do flipping. So this flipping, I'm not going to use the AB anymore. I don't need that. I have two-dimensional array. And here you can specify your two-dimensional array. Let's actually have the data over here. So let's have actually two-dimensional array is array of arrays. So you need to do 1, 2, 3, okay? That's one row. Second row, 4, 5, 6, okay? Third row actually is 7, 8, and 9, okay? Now we have this metric, okay? We have this metric. This one we don't do it, okay? We don't put a semicolon. So this one is a metric of this way, okay? So this is 2D to the 1D one, and column major, we are going to delete them. It's not related to this topic, okay? So right here, we print our metric, and that's it, okay? So let's delete them. So now we actually reset to this condition, okay? We had a print metric, reset metric, okay? And we do print out the M, okay? We do print out our initial value for the metric, okay? So it's like this. Now we are going to do flipping. So this flipping is what? Okay, flipping, you try to have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So that's assume that we are flipping vertically. So we want to flip this one to this side, this one to this side. So the result would be this. Okay, so flip vertically. Okay, so this one we are going to do it flipping vertically. Okay, so let's do this one. Public, okay, static, okay, void, and then let's do flip. Okay, so you have the array metric, okay, here. So now we try to flip it vertically, okay. So here, let's try to use the reverse. Instead of trying new way, let's actually copy the reverse over, okay? So let's copy the reverse 1, 2, 3 all over, okay? All over. Okay, copy everything over. For the reverse 1, 2, 3. So we do reverse first, so we can also use the algorithm for this flipping, okay? So now we have several rows. So each row we do reverse. Then it should be able to flip it. Okay, so let's do this one for integer row equals 0, row less than m the length, and row increase. Okay, so we go through each row. Okay, we go through each row, and then we will do reversal for the row. So 1, 2, 3 will become 3, 2, 1. So here your M0, that is one row, will be equals reverse 1 of your M0. M0 is a row 0. Okay, so here you actually put row. Your row will be reversed. Okay, so now let's do this one. Let's do flip with the M. Okay. And let's print it one more time. So we have an initial metric, and then we flip it, and we actually will print it one more time. And that's flipping of your metric. Okay. Any questions so far? What is a flip B? James Lee, are you okay?
Yeah, I'm good.
Okay. So this flip B is okay. Flip B is easier. Okay. So now how about flip H? Horizontally flip it. How about how to do a horizontal flipping? So let's reset our matrix first, because we are going to reuse it. Okay, so let's reset. Reset is not okay because we kind of need to have the 1, 2, 3, 4, 5. So let's do this one. Okay, let's do copy this guy. Okay, and put it over here. Okay, here I will use new integer 2-dimensional array. Okay, something like this. This kind of reloading the data back to the original format. Okay, this one is reloading the data back to the original format. Okay, so that we finish the reloading. Okay, now we finish that, and we are going to flip H, and then we do print out a new matrix N. Okay, so now we need to do flip H. How can we do flip H? Now this is a problem. Okay, so flip H would be more complicated. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to flip over here. So this one, if we actually traverse a row, it won't work. Okay, it won't work. If you traverse through the whole array, okay, the one way you can do is that you traverse the whole array, and then you copy 1, 2, 3 to here, 4, 5, 6 to here, 7, 8, 9 to here. Okay, that's one way you can do it, but it's very complicated indexing. Okay, so we will do swap based algorithm for doing this. Okay, so let's do this one. Let's traverse the row from the row 0 to the middle row. Okay, only do this one, and we do swapping the columns. We do swapping the column from each one, sweeping the column to the symmetric location. Okay, to the symmetric location. So now that's actually, we need to know about number of row first. The number of row n is equals m times length. Okay, that's the number of rows. Okay, so we go through integer I equals 0. Okay, I less than n divided by 2. We only go over half of the row. Okay, go over half of the row, and every single one here we have integer j equals 0, j less than m's I length. That rows number of columns. Okay, and we go through each one of these. Okay, so this one actually, this whole 2-dimensional traversal will be what? You will traverse through 1, 2, 3, 4, 5, 6, only this. Okay, but when you traverse to here, 1 will be swapping with 7. Okay, 2 will be swapping with 8. 3 will be swapping with 9. So we use this n divided by 2 to control the number of rows we will access, and we will do swapping over here. So here you are going to swap the row. Okay, every column you need to traverse through it. Okay, so let me change it. Okay, don't use I and J. Okay, I and J very confusing. Let me use row and column. So now we are going to swap. So swap, you will be creating temp value equals, here we have the so-called row and column. That's your cell here. Okay, your list cell. Your list cell will be swapping with your n-1 minus r location. That's the row you want to swap with. Okay, I'm sorry. Here you should be okay. This one, I'm sorry. You should have the assign this value to your m r C location with this value. Okay, and eventually you are going to assign this one n minus 1 minus r equals 10 value. Okay, so what this one is that you have 1, 2, 3, 4, 5, 6. Your 1 will be swapping with 7. Okay, and the 7 is here you have row 0. You are swapping with the row n minus 1 minus row. Okay, you are swapping with that row. So here I'm missing the C. Okay, missing the C. But it's okay. Okay, so this one will be flipping H. Okay, compile and run again. Okay, so horizontally flipping. Okay, horizontal flipping will also be tested in AP. Okay, vertical flipping, horizontal flipping, they are all be tested in AP. Any questions so far? Okay, up to here we have quite many programs. So let me upload to chat first. Okay, if you have questions, you can study during the break. Let me know which one you need more explanation. Okay, let me upload to you first. Okay. So week 6, let me have the conversion. And then flip. And then move. So here I try my best to come up with different algorithm for the 1-dimensional and 2-dimensional array. Okay, every single one of them you need to practice yourself. Try to write yourself. Okay, don't just look at a video and then say, oh, okay, I understand it. It doesn't count if you cannot rewrite it by yourself. You must be able to recreate everything by yourself. Okay. Any questions so far? Any questions so far? Okay, so this one is 2-dimensional flipping. Okay, I think we have enough of the things for 1-dimensional and 2-dimensional array. Okay, we try to cover other topic, and if we have extra time, we come back to for it. Okay, for each loop, you must know about what is for each loop. Okay, it's for each element. It's not for each. It's not for each index. Okay, so this one for each loop, you must remember how to call it. Okay. Okay, this one, let's actually try a simple example. Let's try a simple example, okay? Just to let you know what is for each loop, okay? So here, let's assume that we actually have an array. Edit, okay? Integer array A equals 6, 7, 6, 7, I'm sorry. Keep typing the wrong thing. Sorry for that. 6, 7, okay. 1, 3, 2. Okay, let's actually have this one. So this one's an array, okay? So we can do this one. We try to use it for each loop, okay? So for each loop, it's different from regular for loop, okay? It's different from regular for loop. Okay. So for each integer x, okay, from A, okay, we kind of print it, okay? We will print it. Okay, so this is called for each loop. For each loop is for each element. This X is element. This one is not index. So usually I use X. I use X for element. Okay, so for each integer element X, you print now. So it's a content 6, 7, 1, 3, 2. There's no index for this loop. Okay, but if you want an index, you can do this one. You can use I equals 0, and every time you do I increase. Okay, then you still have an index. Any question? Any question about this for each loop? Okay, for each loop sometimes is very useful. Okay, so here I just give you a simple example. We are going to look at other things. Okay, we are going to look at other things. The next thing we would like to look at is two-dimensional array. Remember, is array of arrays. Okay, so here you have a two-dimensional array 3 by 4. It actually store a actually is an array of pointers, array of 3 pointer, array of 3 row pointer. Each row pointer pointing to an array of 4 elements. So here A is 2-level array. A is level 2 array. It's actually integer array. Okay, this one is an array of array. So each one of it is an array pointer. Okay. So remember this level 2, level 1, level 0. Okay. Level 0 is the data. Okay, so that's very important. That's the concept you need to have. Okay, and this is a column measure, row measure. We explained it already. So please check. Please check the slides. Okay, we don't have that much time to go over every single one. Now let's look at array list. Okay. Now let's look at array list. We have limited time, but we try to cover everything. So now let's go to array list. So array list is a list made of array. Okay, so it's a list made of array. So in fact, it's also a array, but it behaves like a list. Okay, and there are also some data type called linked list. So linked list is a list made of linked nodes. It's a list of made of linked nodes. Okay, but first let's look at what is list. Let's look at what is list. A list is a what? It's a data that link with the next data and then link with the next data. So you have 1, 2, 3, okay, and then 4. So that's assume that this is the list. So this is actually a one-dimensional data. Okay. The difference between this and array is array has fixed size. So array, you put 1, 2, 3, 4 there. Your index 0, 1, 2, 3. You can no longer change the size of the array. But here, array list, you are able to create one more data inserted to here. It's okay. So this is actually, array list actually is of flexible size. You can add data into the list. You can remove data from the list. You can copy from the list. You can do index sort to do finding the data in the list. You can compare, you can find a sublist. Okay, sublist is similar to substring. You can use that different feature to work on it. Okay, so that's the feature of array list. Okay, that's the feature of the array list. So array list is a kind of list. Okay, and list by itself is a interface. Okay, list by itself is an interface. Okay, interface is not teaching AP anymore. Okay, but it's actually a interface is some kind of a simplified. Okay, it's some sort of a simplified class. Okay, so basically this is a super class. and your array list implemented, okay? Your array list implemented. Okay, so array list has all the feature that list has, okay? So that's the relationship between this and array list. So you can create an array list of this. Okay, at this moment, when you declare array list of list, and this one array list would be equals null. It's actually, it's only a reference data. You have not created any array list yet, okay? And later you can create the array list body and then assign the object to array list. At this moment, A list will be empty list, okay? And then you start to add data to it. Okay, so let's look at it. Let's look at this array list, okay? So here, let me do array, okay, list tester, okay. And you must include a java.util the star. Otherwise, you cannot use it. It actually is a library, okay? Okay, anyway. Okay, here let's actually create an array list. Let's put the array list of integer. Here must be a object type, okay? If you put int, that's not allowed, okay? That actually is wrong. It must be object type. If you declare this one, you are in trouble. It won't pass, okay? So it had to be the wrapper class integer. So this one, we just do this, and then we try to print it right away. So at this moment, it's a null pointer. It's a null pointer, and it's not even, okay, it's not, have not been initialized. So let me cut this one and put it over here, okay? And this one, okay, we can run it. And at this moment, the array list is null. Null means that this array list is not only empty, but not existing. So your A list has no address at all. Okay, at this moment has not even having any address. Okay, so be careful. Your array list can be null. Okay, now after that we try to do this. Okay, we try to do this. We try to do A list, okay, equals new array list of integer. So at this moment, the array list is being created. Okay, the array list is being created, but it still had no data to it. So right here, this one, we actually create an empty array list. Okay, you create an empty array list by doing this. Okay, it's empty, so no data in there. Now we start to add data to it. So A list dot add 1, A list dot add 2, A list dot add 3. So it adds 3 data to it, and then we print it one more time. Okay. Okay. Any questions so far? So now we add data to it and print it, okay? Okay, so here we review the array list. So there are a few functions you need to remember. Those are 18 function, 18 with index location, clear function, contain function, get function, index of function, okay? Remove function and set function, and size is the number of elements in the array list, okay? Size is the number of element in the list. Okay, this different function you need to remember. Okay. So array list always start with out with empty. Okay, and array list is resizable. Okay, array list require import statement. Arrays can only store object, no integer, no int. Okay, and the function you need to remember are here. Okay, these are the function you need to remember. The function associated with array list you must remember. Okay, you must remember. So the size gets set. Okay, these few things I cannot review for you because it takes a long time to review every single one of them. Okay, but you must know this. Okay, if you don't know, let me know. Okay, I can teach you. But right here, I assume that you know the basic. Okay. Okay, so you can create array list. We already show you how to create an array list. Okay. And now, let's look at the application for array list. Okay. So here one thing is that the first use of the array list is filter. Okay, it's filter. So here let's assume that we have static, okay, integer array. A equals 3, 4, okay, 5, okay, 1, 2, 7. Okay. Then how about if I want to just keep, the even number. I will throw away the odd number. So this one is called a filter. Okay. You can use a filter. So here integer array. Eventually I need to return the integer array. Okay. So I'm going to do filter. Filter what? I get an array and I'm going to filter out the odd number. I only will save the the even number. So here let's do array list of the integer. Let's call it even. Okay. So this even is new array list of integer. Okay. So here we need to import it. So now we need to go through every element in the array and then only keep the even numbers one. Okay. So let's do this one. Let's do this. Okay. Let's do this. Let's do 4. Okay. Integer. So let's actually get the integer. So integer x in the A. Okay. This is for each loop. Okay. So if actually x multiplied by 2 equals 0, then the even will add the x. Okay. And then eventually we will copy it to a new array. Okay, we'll copy it to a new array. So what? So we'll copy it to a new array. So here let's have the integer array B. Okay, we will have the array list. Okay, so let's actually return the array list. You can copy it just using the traversal. So here let's actually return the array list. Okay, so we can return the even list. So now let's have the public and static. Okay, so we print out the A first. And then we do filter. Okay, so we do filter. Okay, so it will return an array list. So let's have the array list. Write A, and then we return with the even number list. Okay, and we print out this list. So first feature is what? Is to filter. Okay. We keep only even one. Any question? Hello, any question? No question? How about Grace? Are you okay?
Yes.
This filtering, do you understand?
Yes.
Okay. Second use of array list, okay, is to creating, okay, remove the duplicated data, okay. You can remove the duplicated data. So what we do is, okay, let's copy this one. Okay. And then we have another array called B, okay. But this B has many duplications. So we have 3, 4, okay, whatever. Okay, whatever, we actually have many duplication. So we will only keep the non-duplicated part. Okay, we get this array, but we only keep the non-duplicated part. Okay, so what we'll do is this one. Okay, we'll do for integer I equals 0, I less than A. Okay, we can also do this. Okay, we can also do integer, okay, x from A. Okay, so here we create array list integer, okay, and no duplicate. Okay, so we check the x if x, okay, if no duplicate contains x, okay, if it's not containing the x, okay, then no duplicate will add the x into it, okay, and eventually we return the no duplicates. Okay, so we create an array list. We go through every element in A array. If the A array's element is not in the no duplicate one, we will actually add it to the no duplicate, okay? And then eventually we return that. So here we create array list of integer ND, okay, no duplicate equals no repeat. Here this was from B, okay? And we are going to print now the no duplicate. This is the second use of array list, okay? First one, you filter out the non-qualified data, okay? Second one, you create no duplicate list. So those duplication will be removed. Is that okay? Hello, is that okay? Yeah, I'm trying to show you how to solve some FRQ problem, okay? because FRQ, if they want you to create no duplicate, this is one way to create it. Okay. Any question? So I'm try my best to review the possible pattern for you. Okay. So let me see. There are one more pattern we may want it. Okay. So let's see here. Let's copy test arrays. Okay. Removal of duplicate. Reordering. Okay. Reordering. Okay. Let's try reordering now. Okay. There's one more algorithm very important. That's actually called reordering. Okay. So let's assume that we have this one. We are doing sorting. Okay. We are doing sorting. You can use arrays to sort it as well. Okay. But that's not using the bubble sort, not using the merge sort, not using the sorting. Let's use only the arrays, using the arrays to do sorting. Okay. So this one public, okay. Static, okay. Void, I'm sorry. This one will return array, okay. And this one is reordering. Okay, let's call it reorder. So give me an array and I'm going to reorder it. It actually is a what? It actually is sorted. Okay, it's actually sorted. Okay, so here let's have here let's still return array list of integer. Okay. So here we have array list of integer. So it is ordered. Okay. Okay, now we are going to reorder the data. Okay, X. Okay, so here for integer. Okay, integer from X from A. Okay, we get every element from A. Okay, we get an element and we start to do this. Okay, for I'm sorry. We actually use integer J equals 0. Okay, so while actually J less than orders a size, okay, and also, and the actually ordered that get J actually is less than, okay. I'm sorry. Here actually your X value is actually greater than this value, okay. The J will increase, okay. So this one will get out of the while loop until J actually X is what? Is actually less than or equal to, okay, here let me also, okay, that actually also use equal, okay. It will be less than, until you stop until X is less than the order that get J, okay. Okay, so you stop here. Okay, so let's assume that we have order. So our order is 1, 2, 3, 5, 10. Okay, so let's assume that the X we look at is 4. So you go through here until, okay, until actually the X is less than the get J's value. So we'll stop at the J location. That J actually is the orders list of J will be bigger than the X, okay. And in that location, what we will do, we will do is actually we will do order at the J location is X. Okay, that's it. And we will return ordered. So this one is using arrays to do sorting. Okay, and it's kind of like an insertion sort. Okay, but it's just very simple and will do sorting. Okay. So that's new order, okay? That's called reorder. So reorder RO, okay? So you have an array, okay? And you will actually what? Do reordering and then return to RO, okay? So here, let me actually print the extra line, okay? And then let's print out the reorder array list, okay? So this is the third use of the array list is to provide reordering of your data sequence, okay? So from this one, okay, this is not sorted, it's just using the array list to create it, okay? To convert it to here. Any question about this one? It's not sorting algorithm. We use array list to do sorting, okay? Any question? Any questions? Okay, these are a few important use of the array list, okay? Filtering out unqualified data, okay? Remove the duplication and then provide reordering, okay? These few algorithms, please must remember them, okay? It will be tested, okay? And that actually is some sort of sorting. The last one I must cover is the removal, okay? So here let's actually have a array list, okay? Let's see, here let's actually create a new one, okay? Let's have static. Okay, so let's have this one C array, okay? And we can load the array to array list, okay? So here let's create an array list integer that is a C list, okay? So C list we can do new array list, okay, of integer, and we can load, okay? We can do arrays that list. We can load the C array to the array list, okay? So by doing this, okay, I'm sorry, this one you cannot use a integer array. You must use a capital integer array. Okay, with that one, let's see what is inside the C list, okay? So inside the C list, we have such data, okay? Now we are going to remove the odd number, okay? Let's assume that we are going to remove the odd number in this list. So this one, we don't return value, okay? So let's remove odd. Okay, so this one, let's call it A list, okay? And we are going to remove the odd number from here, okay? One very important thing is that this will be wrong, okay? So don't do this, okay? This one is an error, error example, okay? So when you do removal of the array element from array list, don't do this, okay? Don't do this, please don't do this. Okay, don't do this one. If actually A list target I, okay, take modular by 2 equals 1. So this is odd number, okay? And then you do A list dot remove, okay, remove I. This is wrong. This one's wrong, okay? Let's see how wrong it is, okay? Let's see how long it is. So be careful when you do removal. Okay, if you need to remove some data if you need to remove some data from a array list, be careful. Directly doing traversal will create trouble. Why? Because let's look at this example here. Okay, so your index is 0. Okay, you check the 1 is you remove. You remove, then your 3 become index 0. So now you advance your index from 0 to 1, you check 4. So 3 will be kept. 3 should be removed because it is a odd number, but it will be kept. So here 7 will be removed, 9 will be removed, 12, 13 will be removed, but 15 will be kept. 17 will be removed. So if there is a 2 element that you need to be removed, you will be skipped because you are passing the index. You're passing the index for it. Okay. So doing this way is wrong. Doing this way, you will actually have some odd number you want to remove, but it doesn't remove. If you actually remove 1 and the index, the 3 location will have index 0 now. So the next number to be checked is 4. So you will check only 1 and 4. 3 will be bypassed. Any question about this one? Any question about this one? So how to fix it? Okay, how to fix it? How to fix it is not don't use a for loop. Let's actually change it to while loop. Okay, and put the integer I equals 0 outside. Okay, so while you do this one, okay, don't advance your index. So if you remove, don't advance the index. But if you do remove, then you advance you don't remove either your element. You increase your index. So in this way, the odd number will all be removed. Okay, why? Because you check 1, the index is 0. You check 1, you remove it. Then you do not advance your index. So your index still is 1. Your I still be 1. So you remove this one. So I become, you will stay 0. Okay, 0 you don't remove. You change it to 1. Okay, 1. Okay, and then you change it to 2. 2 you remove 7. So you remove index remain 2. And then you advance to 3. You remove a 9. Your index remains 3. And then you increase to 4. Increase to 5, you remove 13, and then your index remain at the 5. You remove 15, your index remain 5, and then you remove 17. So by doing that, you will be able to do forward traversal, but you will keep all of the element you want to remove out. Okay, this one very important. This one also openly tested. Any question about this one? No question? Okay, no question right now. We are 7:55, okay? So come back, we have a break for 5 minutes and come back at 8 o'clock, okay? We'll work on the problem set for chapter 7, okay? For this array and array list, okay? We cannot cover everything. There are too many things, okay? So I try my best to come up with the most important algorithms, okay? Okay, so break until 8 p.m. Okay. This time we will get started from the last one. Okay, William Chai. Okay, we'll get started from the last one. So here I'm going to upload this parents problem set to you. Okay, so you can look at it if you need it. Number one is very important thing is please work harder, okay? The college admission, especially computer science right now is extremely hard. Right now it's extremely
Do you
hard.
want me to answer number one?
Yeah, I want you to answer number one, yes.
Is it D?
Okay, I'm uploading the problem set, okay?
Okay.
Okay, so some people who don't have the PDF, please download it, okay? Okay, so here, okay, problem one, which of the following correctly initialize an array to contain 4 elements, each one is 0, okay?
Is it D?
So you know, answer is D, okay? Why not 1?
Because you need to do new int or and then
No,
like new int array.
no,
that.
this one is okay.
Oh,
This
okay.
one's okay. When will it be wrong is like when you do have this one, integer array ARR, and then later you assign this to it, that's wrong.
Oh, okay.
This is wrong. But if you assign it the first time with the data in here, this format is okay. But if you actually declare it and then you want to assign the value to it, here you need to put new int array. Is okay?
Okay.
Okay, so that's the problem one, okay? Problem one. And this one is redundant. You really don't need to do for loop, but actually it's nothing wrong. Okay, that's nothing wrong. Okay, that's nothing wrong. And every week there are about 3 people from this class submit the homework. Okay, so I think that's too few. If you don't practice, you cannot improve. Okay, and usually my experience is that if you work on 5 sets, usually you can climb up more. Okay, if you only have working on 2, 3 practice set, that's not enough. So the best practice for preparing an AP is at least 10 weeks. Okay, 10 weeks minimum to prepare a AP test. Okay. So that's my experience. Okay, that's my experience. Usually, one AP test you need to take 10 weeks to prepare. Okay. I never take any AP in US. Okay, I don't grow up in US, but my 2 sons totally take 30 plus AP. So have more experience than any parents. Okay. Okay, next one, number 2. That has William N. Okay, what's your last name?
Well, I'll change it.
Okay. Because we have 2 William. Okay, sorry for that. If we have 1 William, I think it's okay. So
Yeah.
okay, so Lin. Okay, I'll call you Lin. Okay. Okay, so William, what's your number 2?
C.
Mm-hmm.
Wait, no. B, never.
B, never.
Yeah.
The following program segment is intended to find the index of a first negative integer, okay, in this range, okay, in this range, where array is an array of n integer, okay. So here I equals 0, and while this one you increase it, that's actually is okay. That actually is okay, and but there's one problem. Okay, there's one problem. The one problem you may have is that if they are all positive, okay, they are all positive. What's wrong is that you have, say 1, 1, 1, 1, 1, 1, 1, 1, and then you finish the last one. Okay, you still continue to increase the index, and then you will have index out of bound problem. Okay, they'll have an index out of bound problem. So you can only be breaking the loop only when there's at least one negative integer, then that would work. So the answer is C. Does that make sense? Hello, William Lin, is that okay?
Okay.
So you get out of loop when actually the array element I actually is less than 0, you get out of it. Okay, so only this one, you get out of this. And if you don't get out of this, what will happen is that your I keep increasing until you get array out index out of the bound, then you have trouble. Okay, to avoid that trouble, you must have at least one negative number, or right here, you need to have I less than ARR the length to protect against your index out of bound problem, and then end this condition. So they are missing this one, or they know that at least one negative integer will be there. Is that okay? Does that make sense?
Yeah.
Number 3, let me have Natasha, okay?
Is it A?
Number 3?
Yeah.
No, number 3 is array index out of bound. When we array index out of bound, you keep doing this, okay? So initially your I is 0, okay? You increase it immediately, so you become 1. So the first element added to sum is actually index 1. Okay, keep going. So you go to n minus 1, that's the last element, right? Last element, you add it to sum, that's okay. You go into here, is the last element, but you increase it to n. You increase the n, and then you add it to sum already. So that one will create index out of bound problem. So you have array index of out of bound problem in this problem. So how to fix it? How to fix it is to move the I here. Is that okay? But set this one to 0. Is that okay?
Yeah.
That's how to fix it. Or another way to fix it is set this one to be 1. Okay, and move this one to here. Okay. Is that okay? Anyway, there's some way you can fix it. But this one will have array index out of bound problem. Okay. Number 4, let me have Oscar. Okay.
For number 4.
Mm-hmm.
I'm doing number 4, right?
Yes. So what does this program do?
It's transferring all of the non-zero elements into array 2.
Yeah. So which one?
So should it be A?
So why not E? Why A and why not E?
Wait, sorry. Oh wait, I was blocking the question. Wait, array 2 and you count. And then it's equal to array 1. I'm not completely sure.
Yeah, that's the problem, right? Your answer is correct, but you are not sure.
Oh, because it's only going to take the count number of thingies. Because it moves the non-zeros to like the front-ish, and then when you do the transferring, it only takes the front ones that are not zero.
Yeah.
Because it's like been like decided already.
Yeah, but I mean, wait. Isn't that the problem that the first problem that we talk about today is condensing? Right?
Yeah.
I spent the first half an hour to explain the algorithm you see right here. Okay. So I told you the algorithm is very important. Okay. And I also told you eventually the p-value will be the number of the non-zero element. So here you create a new array with that number of the non-zero element. So the length of the array 2 could only be the length of the non-zero element. So only 3 elements in the array 2. Okay, so that means that please, sir, please spend more time, more focus on class. Okay, we do cover this one, we do explain it. Okay.
Okay.
Number 5. Okay, number 5. Let me have Luke Ma. Okay, Mr. Lu, Mr. Mark.
Right. Let's see. Just a second.
What is the maximum number of times that your small will be printed? Okay, how to solve it? First, how to solve it? Maximum number of times your small can be printed. How to solve this problem? Don't try to look at book or try to search internet. Okay, it doesn't teach you how to solve the problem.
I'm not doing that, but
yeah, you are not doing that. That's okay. But how to solve it?
Well, I'm going with C.
Why C?
Oh. Oh, actually, scratch that. This is something else.
You don't know why is actually how to solve it. How can you pick C, right? That's the problem.
Yeah, I don't know this one.
You know this one, but how can you pick C? C is the answer.
Well, yeah, I started.
Okay. Anyway, I want you to work harder. Okay, that's the number 1, and I'm trying to help you. Okay, so this one you try to find the maximum means that every time you do it, that will be giving you the maximum. Okay, so you are starting from 2 to K. They are totally K minus 1 time, so that the answer is K, is C. Right? So to solve this problem, they are asking for the maximum number of times you will do it. Is that the condition always happen that will give you the maximum. Condition never happen, that will be the minimum. Minimum is 0 time. Condition always happen that actually is maximum. So you will print the small K minus 1 time. From 2 to K, that actually K minus 1 time. Okay? Key point is that I want you to learn how to solve the problem. We discussed this problem set because we want to teach you the exam taking skill, okay? So not only you need to pay attention to the class, but also you need to try to find the way to solve the problem, okay? We review it not because that we want to give you the answer. The answer you can look at the parents' book, right? That's not the whole purpose we're doing this, okay? So also when other students are answering the question, please also be attentive, okay? Also pay attention to it because we are teaching the problem solving skill, but using the problem set, okay? So next one we have KD, okay? I'm not trying to give you the hard time, but trying to teach you how to get prepared for AP, okay? That's my job.
Is it B?
Okay, and how to solve this one. So we do something for the array, right? So the array passed to the do something, okay? And then the array being appointed to the B, okay? B's number being assigned with the I value. So originally you have 1, 2, 3, 4. You become what? You become 0, 1. Let me see. Okay, so initially you have, let's do this, okay? Initially you have array. The array's data is 1, 2, 3, 4, right? Now you do something about the array. Do something about array. The address of the array being copied to the list, okay? So this is pointed to here. And now B also pointed to here. And B's 0 being assigned with 0. B's 1 being assigned with 1. B's 2 being assigned with 2. B's 3 assigned with 3. So after that, you pick array of 1 and array of the 3. You got C. Is that okay?
Oh, yeah.
So this kind of problem, please draw the memory diagram, okay? Please draw the memory diagram. And I draw memory diagram a lot of time, trying to help you to understand how to solve the problem. So you may get it wrong, that's okay. Okay, we don't blame you because we are practicing. But please, after class, try to redraw the memory diagram by yourself. That's the way you will improve, okay? So here I don't try to find back hard time for any student, but I do want you to pick up the exam taking skill, okay? That's the key point. Key point is that you must learn how to do it. This one, let me repeat one more time. Your array originally pointing, it's a reference data, so it's holding the address. So it's pointing to 1, 2, 3, 4, right? So you actually call the function. Call the function is to copy the address value to list. So list also pointing to here. Now you declare a reference type B using the address of list. So B is also pointing to here. Now B goes through it, and every single element of it actually update the data with the index. So this one become 0, 1, 2, 3. Now B change the data, array also see it. So you pick the index 1 location and index 3 location. Then you should print out 1 and 3, okay? Okay, number 7, this one, let me have James Lee, okay?
Is it D?
How to how can you solve it? Okay, so here we have a program that read the line of the text file into sequential list of line. Which of the following is a good reason to use array list instead of array of string? What's the good reason for it? Because array list is flexible length, right? An array is not, right? Is that okay?
Yeah.
because you don't know how many lines the file would be. Okay, the D is correct, right? Okay, next one, number A. Let me have Henry. Okay.
Yeah, just give me like 20 seconds just to like read the question and stuff.
Yeah, read the question. So why you want to use an array instead of using array list? In what condition you like to use array?
Is the answer A?
An array of perimeter data type is more efficient to manipulate than an array of wrapper class type. Okay, we keep it. So why B is wrong?
Array is immutable.
Array is immutable.
Yeah.
But you can update the length. You can redo redirection. Okay, but it array list is also made of array. Array list is also made of array. So basically, insertion to array or array list actually is equal. You don't get any advantage of using array list than array, or using array over array list. Those actually are equal. So B cannot be the answer. Okay. C, remove all the element from this is easier to call. Yes. It's easier to call from here. But here, let's see. Which are the reason to implement array of integer code. So here we are preferring array, not preferring array list. So we are not talking about, okay, removal from array is easier to call for array. No, it's wrong. Okay, this one is also wrong. The accessing individual value in the middle of the list is easier for an array than array list. Sorry, array list is actually implemented by array. So actually the efficiency is the same. So wrong. Accessing all element is more efficient. Wrong. Two are the same data structure. Array list is made of array. So you use array or array is no difference. The only thing is that A, you manipulate integer will be faster. Okay. Okay, this one, number 9. Number 9, let me have Grace. Okay, Grace Jean. Okay, here the proper statement is long, but please look at the PDF. Okay. So here pretty much you have address that has many data fields, okay, and getters and student with many data fields. So now, number 9 is that you create an address of 100 elements, okay, and how to generate list of the names only. Okay, so here you have the list. So this one is testing you about for each loop.
Wait, give me like 20 seconds.
Number 9. Number 9, you need to read this part, but not that important. It's testing you about for each loop.
Is it C?
No, it's D. You can directly pick this one because you don't need to read the previous part. Why? Number 1, it cannot be class name. So class name is wrong, right? Number 2, there's no index. So there's no such thing as this I. Number 3, the C also no index. So this is wrong. Number 4, you actually has the element A. So D is correct. Number 5, the list you cannot use the whole list to get name. This is not an address. So the answer is D. It's a very easy pick. Okay? Is that okay?
Yeah.
Remember, this is for each loop. For each loop, there's no index. So A, B, C are all wrong. You look at the bracket with the index that already wrong. You don't need to look at it. Okay? This A, B, C already wrong. So you only have D and E left. D and E left, you pick element or you pick list. Of course, you pick element. Element can get name, list cannot get name. Okay. Number 10, let me have Eric Yu. Okay. This one's 1, 2, 3 problem. So tell me, it actually is for each address, how to print out the address correctly. Okay. It's actually also for each loop.
Just give me a second. I need to open up the file. Having a bit of technical difficulties on my end, so could you scroll up a little bit?
You only do a for each loop, for each address in the list. Which one can give you the right answer to print out the address for your elements?
Is the answer C?
C. 3 is correct.
Yeah, I think so.
Okay. 1 is wrong. Why? 1, I would say never look at it. What is wrong? Why?
Because you don't have the variable I.
You don't have an index. Okay. It's for each loop. So 1 definitely wrong. 2 is correct. 3 correct or not? How to determine whether 3 is correct or not?
I think we need to know if the address class has a toString method.
Yes. Okay, good. So at least you know this. That's good. So go back to see address class. Is there any toString?
No, I don't think so.
No. So 3 is wrong. So the answer is B2 only. Is that okay?
Yeah, that's okay.
So please must know about how to solve it. Okay. Each problem you need to know what are they testing you. Okay. Okay. Number 11. Let me have demo when. Okay. This one again is for each loop. Yeah, this one again is for each loop. And then try to do what?
I think it is. Wait, yeah, C.
So why A is wrong?
Because I think first you have to go to the address class because that's where you can use a get name.
No,
So.
A is wrong because this one is the array.
Oh yeah. Oh, I thought you were talking about the circular.
How about B? Why B is wrong?
Because you didn't access through the accessor for the.
You don't get to the edges. How about C correct? Okay. And how about D? What's wrong with D?
Oh, same with the all students.
Okay, you don't have that. How about E? Why E is wrong?
You don't have index for.
Okay,
for
you don't have index. Okay, good. Next one, number 12. Let's go to Amy. Go away again. Okay. Anyway, number 12. Okay. Number 12. Let me go back to William side. Okay. So here is 1, 2, 3 problem again. Okay. And then they are student. I think they are student, but this one you have a student. Well, is this one linked with the previous problem or not? Let me look at it. Okay. This one is actually problem 9 to 12. So still the same ages and student. Okay. So number 12. This one, you need to look at PDF. Okay, it's too long. So basically, you have a student and locate student okay, you have the student array. And then which of the following so that the method works as intended? So student with highest ID number, okay? You would try to get the student with the highest ID number. So there's a finding maximum problem. Okay, so there's a 1, 2, 3. So which is correct answer? Let's look at 1. Is 1 okay? Is 1 okay? Hi, William Tsai, hear me? Let me make sure you are there. Hello? Hear me? Okay, I'll pass. Next one, William Dean, okay? Can you work on this one?
Can you scroll up?
Yes.
Oh.
Okay, so look at the 1 okay or not?
Oh wait, I'm still reading the problem.
Yeah, you read the problem, it's okay. Take your time, okay? No rush. This one is a finding maximum problem, right? Remember, it's a finding maximum problem.
Can you scroll down for the options?
My question is like, is 1 right or wrong?
It's right.
No, it's wrong.
Oh.
1 is wrong, but where it is wrong?
The end return statement is wrong.
Which one? This one wrong?
Yeah.
No, this one is correct.
Oh.
But which one is wrong? This one's wrong. This one's wrong because you find a bigger one you already returned. That's wrong. That's not a maximum. You need to compare every single one before you can make decision. Okay, to be actually both of them are wrong. Actually, both return are wrong. You cannot return the value right away. You find the maximum and you return. That's wrong. You need to compare through the whole array until you determine the maximum. You cannot say, okay, there's a one bigger than the first element, and you already return it. That's wrong. Okay, that is wrong. Okay, how about 2? 2 okay or not?
Yeah. Wait. Yeah.
2 actually you get the maximum from the ID number. So that ID one is the maximum. So every time you compare the student's ID with the maximum, that's correct. And then you pick up the highest student so far, and then eventually return the highest. So 2 is correct. 3, you actually have a maximum position. So you compare the maximum positions. So you keep track of the maximum position. So maximum position is an index for the maximum student. Okay, so 3 is also correct. So the answer for this one is 2 and 3. Okay. Okay, next one. Next one we have Oscar. Okay, the Oscar you work on 13. So there's a ticket class. Okay, transaction class. So you may need it, but look at the problem and then go back to check the class. Usually this kind of problem, don't read the whole class, okay? You just know that what information are there and go here to work on it, okay? So this one pretty much is to how to create a new ticket to the loop, okay? So it actually is called to mode, okay? So here you kind of had a transaction. For each transaction, you are going to create every ticket for the new tickets, okay? Every ticket for the new ticket. So how can you create every ticket for the new ticket?
Would it be B?
Okay, so why A is
so the problem with A, C, and yeah, so the problem with A and C is that they all say get row, and you're not really getting anything. You can't really, yeah, you can't, yeah, the object hasn't been created yet. You can't get from a non-existent object. And then the
no. Here the row and the okay. Here you are in the transaction class, right? So you have a number of ticket, okay? So right here you do have a value here. It's the row, the seed, the price. Okay, you have a row, seed, and price, and you are using this data, okay? So there's no object at all. There's no object at all. There's not even object there. So there's no get row. So, okay, is this one, no object, so get row are wrong. Okay, and then what else is wrong?
The problem with D and E is that it should say ticket, not ticket list. There's no ticket list.
Yeah, okay. So basically, originally you use a ticket, you already keep only A and B, C, D, E are wrong because this is not using the ticket list, okay? And then only B can be used, okay? Okay, thank you. Next one, I mentioned Natasha, okay? Natasha, number 14. So, which represent correct calculation of the code to calculate amount? Total paid, okay? Total paid measure, so total paid measure is here, okay? You have total, so you need to sum up. This is inside the transaction, and transaction, I'm sorry, this one actually is not transaction, okay? Okay, it's actually inside the transaction. So transaction have many number of tickets, and you need to calculate total pay, okay? And then which one is correct? And you try to explain every single one why they are wrong, okay?
Is it?
Okay, B must be wrong because every time we see it, you don't use a list to get something, right? So that's wrong. Transaction T is transaction object, and that can never be used. So here is wrong. Here this one's wrong. So we only have A and C left. So which one you should pick?
C.
Why not A?
Is the method name get price instead of just price?
Well, why I cannot use the price?
Is it because it's a private variable?
Yeah, because it's private variable. Go back to check.
Okay.
Because it's private variable. Okay, private double price. You have to use a getter to get it. Okay.
Okay.
Okay, we go through this problem, say we want you to really know it, okay? So that's why I keep asking why this is right, why that is wrong, okay? Number 15, let me have Luke, okay, Luke Ma, okay? So we will create a array of transactions. Which one is the right way to create transactions? Array of transactions. Look, hear me?
Yes.
Okay. I just want to make sure you are listening. Okay, it's okay. Take your time. Okay, not rushing you.
Number 15 then.
Number 15, which one is the solution?
I'm going with D.
Yeah, D. We need to create a list of transactions.
Oh.
So the data type need to be transaction. So this one is a very easy pick of A.
Yeah, okay. A.
Okay. And why B, C, D, E are wrong? Can you create transaction assigned to ticket? Or ticket to transaction? These are all wrong, okay? You never do that. Okay. Anyway, next one, KD, okay. Number 16.
Is it B?
Okay, this one B. Okay, let's see. This one actually, there is a for loop, okay? So you set the minimum to location 0 is starting from 1, and then you less than 1. Okay, you already use I increased. So it jumped to 2. That's one problem, okay? And then second problem, you have array index out of bound problem. Okay, so this one definitely wrong. So what you will do is that you set to 0, make no change. You set to 0, make no change. No, you actually will still run into problem. The while loop, you will run into problem because your index will advance and you will get into trouble. Okay. So 2, okay, let's look at 2. 2, you actually compare this one, I increase, okay? So change the loop body. So this loop body, forget about it, okay? Forget about it. You actually compare the number and then increase it. So 2 is okay. 3, you actually less than equals n, no. 3, you always had this plus problem. Once you increase it, you will have an array that's out of bound problem. So only answer is 2. Okay, only 2 can work. 1 and 3 still suffer the I increase, and then you compare array I to minimum. Okay, that's the problem. Here, once you I increase to 8 length, then the next statement you would have array index out of bound problem. Okay, so that's not okay. Number 17, let me have James D, okay? Okay, here you have some for loop and trying to understand how it works, okay? This is the kind of problem that comparing how it works, okay? Hello, James, hear me?
Yeah, I'm
Okay.
still reading the question. I'm just guessing like B. I'm not too sure on this one.
You're guessing.
Yeah.
Okay, so you have the array V. So how to solve this one? Let's actually put some example. Okay, so V and W are both increasing. So let's assume that it's a 1, 2, 1, 2, 3. I'm sorry. Let's use a 1, 3, 5, 7, 9. Okay, the other 1, 2, 4, 6, 8, 10. Okay, let's assume that V this is that is, W this is that is. Okay, because without number you can hardly imagine. Okay, so basically while this one actually inbound, W also inbound, you check the data. Okay, you check the data. And then if there is some value that's actually equal, then you will return true. Okay, so as long as there is a common value, it will be true. Okay, otherwise, if actually if actually V is bigger, W is bigger than you advance V. V is bigger, you advance W. Okay, so by doing this, you keep moving until one of them is out of bound, then you return false. Okay, so this one is to see if there is a common value. Okay, so okay, if the method had not been exited, okay, if never have not been exited, so here you are still in the loop. Okay, you're still in the loop, and then true at every execution of the loop. Every execution, at the end of every execution of the loop, means that V index and W index, there's no common value. Okay, we haven't exited, there's no common value for a certain range. So this one, the answer for numbers, this one's number 17, it is actually no common value, no common value, no common value, and the index V, this one, and then index that's then equals M. Okay. So here you increase will go to the next value. Okay. You go to the next value, so you can only guarantee up to index -1. There's no common value. So B is wrong because the range is wrong. D wrong, here wrong. Okay. And then N and M is the length of the array. So here you have a this one that's then equals M-1 or N and M. Okay, that's then equal or that's then equal. So eventually you will get out, and then N B index maybe equals N, possible. Okay, possible. So the answer for 17 is A. Is that okay?
Yeah.
Okay, because you may update to N, and then after that you haven't finished. After that your loop may break, so it should be less than equals N. Okay, and N it will jump out of the loop, but it's saying that at the end of the loop. Okay, at the end of the loop you may have one bigger value. Okay. Okay, next one. Let's see. Okay, number 18, we have a class book. Okay. And here we have a problem. Last time we have book. Okay. So this time we have Katie, right? Am I correct? Oh, I'm sorry. Last time is James, right? Who is the last person? Hello. Yeah, I think the next one is Henry, right? So Henry, can you try number 18?
Yeah. I think it's B.
B. Okay, let's see. So you have a book class. This one you read it later. Okay. So you create a book array. Okay. Suppose the book list is actually a book array. So it has a title, author, whatever. Okay. So here for each book you do change status. Okay. Which is true about this code. Okay. The book list array will remain unchanged after the execution. This one, no, it may be changed. Okay. Because this one is available, is a reference. You will call the function, it may be changed. Second, each book in the book list array will have its checkout status changed as intended. Yes, the status will be changed. So B is correct. C, an null pointer may occur. Okay, suppose the book initialized, so each book has a title. So basically it's been initialized, so the null pointer cannot happen. D, a runtime error will occur because it's not possible to modify the object using enhanced loop. No, it's possible. It actually reference available, changing status is okay. But remember, it's B still be a local variable. Okay. D, a logical error will occur because it's not possible to modify the object in array without accessing integer. No, it's possible. Okay, it's possible. Number 19. Let me have Grace Jean. Okay.
Let me see. Is it D?
So here we have a bingo card class, right? And there's in the bingo card is actually have an array of cards, right? Okay, so here the question is, which line is the correct replacement for declaration of bingo card? So declaration of a bingo card is where? A program that simulates the bingo card, declare an array of bingo cards, okay? So bingo card is actually a class, okay? And they have a number of elements, players, okay? So here you must have the object, so integer cannot be, so B is wrong. 20, you need to have the number of the players, so it's not 20. Okay, so here your integer array accepting the bingo card is also wrong. So we only have these two left. Integer is not possible, it's wrong. So you can only pick D. Is that okay? Hello, is that okay?
Yes.
Okay, number 20. Number 20, let me have Eric Yu. Okay, Eric. Which one is correct?
I think the correct answer is C, 3 only.
3 only? So here we have prayer, right? So prayer is an array of bingo card, right? So array of bingo cards. So you get bingo card and then, wait, what's wrong with one?
You can't use a for each loop to modify something.
No, it's okay. This one just because it's a local variable. Local variable, you create an object assigning to card, it's local variable, it's wrong. But if the card actually running some function to modify it, it's okay. But you cannot create a new object to assign to it. That's only a local variable card will get a bingo card. So this one's wrong. Okay. So this one is not. Here your prayer is an array, right? array have many bingo cards, right? So basically you are getting the address of this one copy into car. So car is also pointing to here. Now you create a new object and then car pointing to there. This card have nothing to do with the array. Okay. And car is not indexed, so this one's wrong. So you can only pick 3. Is that okay?
Yeah, that's okay.
I'm trying to explain it, okay? I'm trying to explain it. Number 21, demo, okay, demo win, 21.
Give me a second. I think C. I'm not sure.
So what can be added to the string list?
Wait, sorry, what?
What can be added to the string list?
Oh, in string list.
What can be added to string list? What kind of thing can be added to string list?
Reference.
No, only string can be added to string list. So which one is not string?
Oh, B.
No, B is a string. B is new string.
Oh, wait.
Why B is not a string?
Wait, my bad.
Right?
Yeah.
Mm-hmm. So which one is not string? A, B, C, D, E, which one is not string?
E.
Yeah, integer plus number is integer. Is that okay?
Yeah.
So D is, E is wrong. Other things are all strings. Okay, 22. Let me go back to William's side. Okay, William, hear me? Hello, hear me?
Yes.
Okay. So number 22.
Would it be A? I think it's A.
22, you have a list of integer, okay? Which of our statement will not cause error? So it will be correct.
Oh, would not. Oh, I read it wrong. Sorry.
So which one is correct? You get sick and then you assign to upgrade. Do you have sick to be get?
Yeah, that doesn't work because it would be 0 through 5. But
it will
is that
it actually is index out of bound, so that's wrong. Okay. How about 2? 2 okay? B okay?
I don't know because I thought add was like a void, so you couldn't be assigned to an integer.
No. You cannot add a floating point number to integer.
Oh, you can't. Yeah.
You can't.
Okay.
Okay, so this one's wrong. How about C?
I don't think it has index 6, so it can't do that.
No, C is a correct answer.
Oh, is it because
you have 2, 5, 7, 6, 0, 1? Okay. Add function is the only one you have one more location to be inserted.
Oh.
That's the only one that has the 6 available.
Right.
You can add to the tail. Okay.
Okay.
So C is the answer. Remove no 6. Set no 6. So basically,
I have a question.
Yes.
So if B was not 3.4 and it was just 3, would it have worked?
You add it to here, you'd have to know about adding function, would that return integer or not? Right?
I don't think it does it?
No, it doesn't.
So it still wouldn't work, right?
So it's still wrong.
Okay.
Adding function would be void type.
Yeah.
Okay. So no, it's wrong. Okay. But it actually is a good question. Okay. It's a good question. So you have to review it. Okay. Okay, we are over 9 o'clock, so we still have plenty, quite a few questions, so we cannot finish it. Okay. The thing is that we really spend too much time on this. Okay. We start 8 o'clock. We spend 1 hour. We only work on 22 problems. Okay. And you are allowed to have 1.5 hour to work on 40 problems. So basically that actually doesn't match. Okay. The efficiency is too low. Okay. Efficiency is too low. So I mean, most of the students are undertrained right now. Okay. Not only you need to know how to do it, but also you need to be efficient enough in answering the problem. So remember, every week before the lecture, please practice on the parent chapter. Also review the material. You are not coming here just to start the problem and then trying to find answer. You should review it yourself. Okay. And our review basically is teaching you the exam taking skill and also answer your question. Okay. And you need to spend more time. We only have 1 more month to go. Please work harder. Okay. Current efficiency level is too low. Not going to help you to pass fine. Okay. Most of the students, some students may be okay, but not all of you. Okay. Okay. That's it for today. Thank you. Any questions so far?
Thank you.
Okay, no question. We are that's it for today. Okay. Thank you. Good night.
Thank you. Bye bye, guys.
Bye bye. Bye bye.